Welcome. Let's solve Leetcode 2116. Check if a parentheses string can be valid. Okay, so let's make this bigger so we can read this better. So typically I present a video using Python, but I thought I would also present a video in C++ as well. A parentheses string is a non-empty string consisting only of open and closed parentheses. It is valid if any of the following conditions is true. I'm actually not going to go through this because uh, I think for most developers, we should at least know that, well, our goal is to have something like this, as something like this, where it makes sense how the parentheses or valid syntax in terms of parentheses. So we want something like this. And I just feel like their explanation is quite convoluted. But again, just our parentheses match up correctly. That's the essence of the problem. They do present a twist that makes the problem slightly more challenging. You are given a parentheses string s and a string locked, both of length n. Locked is a binary string consisting only of zeros and ones. For each index I of locked, if locked I is 1, you cannot change s of I, or the ith index of s. But if locked I is 0, you can change s of I to either open or close parenthesis. Return true if you can make s a valid parentheses string, otherwise return false. Okay, so let's go over this first example. So in this second row here is the string s, and on the first row is the string locked. And these red squares or cells indicate that the string is immutable or locked at those locations. And everywhere else, if we would like, we can change the open parentheses to closed and closed to open if we so desire. So notice here at the 0th index of s is we have a closed parentheses, and that is not valid syntax. So luckily, it just so happens that according to the locked string at index 0, we can modify the string or the character at index 0 of s so that we can change it from a closed parenthesis to an open. And if we move on to the first index of s, we have a closed parenthesis as well. And at this point, indices 0 and 1 perform a valid pair of parentheses. Moving on to index 2 and 3 of s, we have an open and closed parenthesis, and those, as they are already valid. Looking at index 4, again, we have a closed parenthesis, but nothing prior that would match it. And looking at index 5, we have also a closed parenthesis, nothing prior that would match it. However, index 4 of locked indicates it is unlocked, so we can change it if we would like, and we do want. So we can change it from a closed to an open. In that case, these strings or these last two parentheses after the modification would become valid. Okay, and hence they return true, because the task is to return true if you can make s a valid parentheses string. Currently, as it originally stood, it is not or was not a valid parentheses string. After some modifications, namely the blue cells, this is a valid parentheses string. Okay, let's go over these last two examples. As we can see already that s is already in a valid state, hence the return value is true. Lastly, we have a string with a single closing parenthesis. So it really doesn't matter if it's unlocked or locked. So we should take note that anytime we encounter a string that is of odd length, we can return false. Okay, so I think that's enough for us to get started. So let us begin. Let's maybe, I'll just move this off to the side and make it bigger for us to begin working. Okay, so let's first get the length of the string. So int n equals s dot size. Now let's check if the length is of odd length. If it is, we can return false. So I'm going to use a bit operator here. So if this returns 1, then we can return false. And okay. Next, let's go over what we'll do here, or the approach will be. So I'm going to actually just going to initialize something here. So I'm going to say stack of int values, s and u. And so what we'll have here is we'll have s is a stack of open parentheses indices, and u will be a stack of unlocked indexes. So why are we doing this? So let's go over that. Why is it important? So the reason why we're doing that is because suppose we have this. Suppose our string looks something like this. Looks something like, let's say this here. Suppose this is our string, and our unlocked looks something like, okay, so if we encounter so let's move this off a little bit just so we can get a good visual of it. So if we encounter this particular situation where the very first character of the string for s is locked and it's closed, we know that we can return false. So if we encounter a locked invalid state, we can return false. Now, however, what if the string was this? What if this? Sorry, so the string stays the same, but this is our locked string. So suppose our locked string looks like this. We have a 0 here and a 1 here. So now, what stands out to me is that when we encounter an unlocked state, so when we encounter an unlocked index, we should save it. We will save it for future use. So what I mean by that is this: if we see this locked and it's available, or it's open, it's unlocked, we should save it. So, okay, so then we'll store it here. So then in this case, we would store u.append the index. So then in that case, we'd have, we'd have something like u equals, and I'm going to use Python syntax here. We'd have 0 here. Now, when we arrived at this index, we'd have a problem because we would want to, the hope is that we would use this closing parentheses to match with an open parentheses. And currently, if this is our first index, the only character that we've encountered is this unlocked one. So my point to you is that when we encounter an invalid state, we ask ourselves, so if we encounter a locked invalid state, we can return false, unless we have previously encountered, or let's say we have unlocked indices available. Okay, so let's see how we can use that to our advantage. So in this case, we would, right? We encountered an unlocked state at index 0. So that means if we wanted to, when we encounter this state, this isn't good because we wanted to match it with we would prefer if this was like this. So we don't have that now. However, because it's unlocked, they tell us that when we have an unlocked index, we can change it to whatever we want. I mean, meaning in terms of parentheses, close and open. So let's do that here. So let's say, okay, so for int I equals 0, I less than n, I plus plus. So what's most important, or what's most valuable, is having these unlocked indices. So we'll check for those first. So we'll say if locked of I equals unlocked, then we can add it to our stack. Okay. Otherwise, else if s of I equals an open parenthesis. Remember, the sole purpose of the s stack is to store indices of open parentheses locations. Okay. So once we encounter that, we can just s.push I. Okay, so let's okay. Actually, I would like to do is just to make sure we're progressing okay. Let's return. I'm just going to return false, and I just want to make sure that everything is syntax-wise is okay. Okay, so it is. So let's maybe continue. So now we have this last scenario. So what is the last scenario? The last scenario says if we've reached this point, we have a locked closed parenthesis. So that's singular. If we have an E, that's plural. Okay, so if we have this, if we've reached this point, we've reached a locked closed parenthesis. Okay, so what do we want? Or what do we need to do? Or what would we prefer? So if we have this, we're hoping that there is an open parenthesis on the stack. So we say something like if not s.empty. So that means on this s stack, that means, remember, we're storing indices of open parenthesis locations. So just suppose we're at index 7 now. Somewhere along the way, maybe at index 5, for example, we encountered an open parenthesis, and we can basically match this closed parenthesis at index 7 with this open parenthesis at index 5. So we'll do that. So when we match them, we can basically remove both of them, or remove this from the stack because it's been accounted for. So let's do that. So we say s.pop. Okay. Now suppose there is no open parenthesis previously encountered. Well, what else do we have available for us? Well, we can also check the unlocked indices. So let's do that. So we say else if not u.empty. We can do the same thing, u.pop. So we'll use one of our saved unlocked indices to match with this locked closed parentheses. Okay. And lastly, well, so we checked our stack for our open parentheses that was supposed to match this locked closed parenthesis. Next, we try checking if we have an unlocked available to apply to this locked closed parenthesis. At this point, we have nothing left at our disposal, hence we can return false. Okay, I'm actually just gonna make sure our syntax is correct. Okay, good. Carrying on. And now we can continue. So where are we? Okay, suppose we've completed our for loop here, looping through all of our strings, or all of the characters of the string. Now we have some possibilities that we need to account for. Suppose our stack looks something like this now. Our stack has characters remaining in it. Suppose our stack looks something like this. And remember, this S stack just stores open parentheses. Sorry, open parentheses. I apologize. Now remember, our stack doesn't actually hold parentheses. It actually stores indices. So it wouldn't look like this. It would look something more like maybe 1, 5, 7, 11. These would be the indices of or indexes of unmatched open, unmatched open parentheses. Okay, that's what we would have here. Ideally, we would have available unlocked indices available to match with them. So we can say something like maybe U looks like maybe 0, 4, 6, and maybe 19. So this would be the indices of unlocked, what do we call it? Yeah, unlocked indexes. Okay, so what we want to do is we want to say maybe we can apply one of these unlocked ones. We can match one of these. Maybe we can match some of them, or maybe hopefully all of them. Okay, so let's do that. So we'll say while not s.empty and not u.empty and s.top. Now let's check something out. So here we have, these are open parentheses. So it looks something like this here. So what we need, or what we want, is we want this to be after that. So hopefully that makes sense. So like, for example, if this was 9 and this was 11, well, remember 9 is before it, so we would have something like, something like this before it. It doesn't matter what it is, open or closed. But ideally, we want something over here that's unlocked, something over here that's unlocked that we can use to match with this. So in this case, let's suppose it's 19. Well, this would be great because somewhere down the road, if whatever this is, we could change this to be in a closed parenthesis because it's unlocked. That's one of the values of it, the importance of it, is that at index 19, we can change this to be whatever we want. And since we have an open parenthesis, we want this at 19 to be closed. So if that's so we need this value to be less than this value. So s.top has to be less than u.top. If this is true, well, we can remove both of them because they can be matched together. So let's do that. Let's remove them. So we say s.pop and u.pop. Now, if we were considering these two indices, notice how suppose this is index 7, but our wildcard, our unlocked index is before it. But we need something after it. We need something over here. We need something over here to apply to it. Since there's nothing to apply, well, that would indicate failure. So we could say, so after we exhaust this while loop here, we need to check if there's still elements on the stack. So not s dot empty, the open parentheses stack. If there's something still on it, then we know that we couldn't match anything with it, so we can return false. Otherwise, we can return true. Okay, let's test this. Okay, looks good. What I'm going to do is remove some of those comments before I submit it. So we don't need this here, and what else? We don't necessarily need this or this. Is that it? I'll leave those there, and we don't need any of this. Okay, so let's submit it. Okay, looks pretty good. Okay, so if you found this video helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.